In this video, we're going to be learning about PSUs, and whether you're an expert PC enthusiast or have never heard about PSU or don't know what it means, then in this video, you're going to be learning something new. We're going to have a conversation with Dio, who's from Enermax HQ from Taiwan, and he will be explaining some of the basic and more advanced topics about PSUs. So ATX 3.0, PCIe 5.0, is there a difference? Why is one or the other? Or ATX 3.1, and if you need to worry about that. Amazon Music Unlimited. I'll give you the best news from the get-go. If you sign up for the Amazon Music free trial through the links in the description below, you don't just get 1 month free trial, not 2, not 3, but 4 month free trial of Amazon Music. This is limited time only, so act fast through the links in the description below. So Amazon Music has over 100 million songs and podcasts, so whatever you're looking for, they've got it. Listen anywhere, offline and online, ad-free. Now you can also use your Alexa devices to voice command ask Alexa to play any song or podcast you want. We find it especially convenient when cooking in the kitchen. So sign up for the free trial right now through the links below and get 4 months for free. Limited time only, so act fast. If we start from the very beginning, what is a PSU and what does it do?
So basically PSU stands for power supply unit. And the primary function of power supply unit is to convert AC, which stands for an alternating current, to DC, direct current. Direct current is for the internal components of your computer. So you can think that PSU is the heart of your computer. So basically it pumps DC electricity to different components of your system, like motherboard, your graphic cards, M.2 SSD, and cooler fans, and so on and so forth. So I guess the question is then, why do we need to convert AC to DC? Yeah, so a very simple explanation will be that AC is constantly changing its direction, right? It's what we call a 50 to 60 hertz. It means it changes direction 50 to 60 times per second. So it's really hard to be used in delicate devices like computer or phones. But DC, direct current, it flows in a constant direction. So it's a lot easier. If you watch the movie Current War, and Benedict Cumberbatch, the movie is mostly right. Like AC is capable of long distance transportations. So it makes more sense for power and for energy companies to use that. It's more commercially viable for them to use AC. Another thing is the PSU we talk about here primarily is for the PSU for desktop computer. So it's a power supply unit for desktop computers. When we talk about laptop PSU is really just an external adapter. It just basically focusing on converting AC to DC in a very linear way. But a desktop PSU, it's more delicate, right? You need to give out a lot of different DC voltages for different components like graphic card or CPU.
So when we talk about power supplies and when people are looking for power supplies, there's a lot of different phrases and what are written on the power supply that perhaps if you're building a PC for the first time, you're not exactly sure what they mean. I want to ask you to explain some of these to us. So we're going to go more in detail as well to like more advanced users about some of the ATX 3.0 specs and so on. But we'll start from the beginning to learn about everything so that whoever is watching this can actually understand everything about this conversation. But there is one of the things that's on the power supplies that says 80 plus and then some kind of metal, 80 plus bronze, silver. So silver, yes. I don't know if we have silver anymore. Gold, titanium, platinum. So could you explain what does the 80 plus rating mean on power supplies?
80 Plus is an organization that basically tests power supply for its efficiency, right? So it's a very old organization, start from like 2004, before we care about environmental efficiency, a long time ago. So like we discussed before, so power supply convert AC to DC, but the result of the conversion is not 100%. So in the conversion process, we lose some power. So that's what we call an efficiency. The 80 plus rating actually has a lot of different levels. We have, from lowest, there's bronze, and then silver, and then gold, platinum, titanium. So basically, the higher the certification is, the less energy it wastes. Basically, the lowest level, the bronze level power supply, only has 82% efficiency. It means it wastes 18% of power. So a gold version, a gold level has 87% efficiency. A platinum has 89%, and the highest is titanium. Titanium has 94% efficiency. So it means that when you put in 100 electricity in, 94% of that gonna be transferred, and only 6% of the energy are wasted.
So if we go more in depth about this efficiency rating, is it always at every level the same efficiency? So for example, if we use the power supply on 20% load or 50% load or 90% load, is the efficiency always exactly the same? So let's say our power supply is 1,000 watts, right? So it's easy numbers. If our, power PC pulls 500 watts of this or 900 watts of this or 200 watts of this on idle, is the efficiency exactly the same or is it different?
When we talk about power supply, we have different loadings, right? It's usually 10%, 20%, 50%, 100%. So the stability or the efficiency of power supply usually peak around 50 to 70%. So usually, let's say we have a bronze power supply that is 80% efficiency. And when it is operating at 50% to 70% load, it actually has slightly higher efficiency rating. So it's crucial when we are using a power supply or when you buy a power supply. We want to keep our power supply operating at this specific loading, like 50% to 70%, not too high. So number one, it will increase longevity, and number two, it will slightly increase efficiency.
So it's a good idea to actually buy a power supply slightly above your needs rather than, okay, my PC uses 650 watts, let's get a 650 watt power supply, but getting a bit more is actually more efficient and makes the power supply last longer. Is that correct then?
Exactly. Yeah.
Another thing that you often see marketed on the power supply boxes is Japanese capacitors. Tell us why this is important. Why is, I don't know, German, why isn't, American capacitors worse? Or why is Japanese capacitor important on a power supply?
Well, number one, I don't think there are a lot of capacitors manufacturers out of Asia right now. But then right now, Japanese capacitors, again, refers to capacitors manufactured by some established Japanese companies. They are known for their high standard for quality controls and consistency. So basically, they hold a little higher quality control. So people like Japanese capacitors because it increase power supply's longevity, stability. It keep their failure rate rather low, and enhance the performance. So it's very reputable for people to use Japanese capacitors. For people who might not know what capacitors is like this. Actually, I have a little sample here. This is a very old power supply. So capacitors is those things. This is the main capacitors. And we also have a small one, little capacitors. So power supplies are basically made out of different capacitors. So then the level of the capacitors are usually decided by where they made it. So in this case, Japanese capacitors are the best. But the very interesting part is when you look at, like, for example, when you look at an Amazon page or a brand page talking about a power supply, there are usually 4 different variations you will see in terms of capacitors. The first one is, and there's no Japanese capacitors. Like the web page just does not mention Japanese capacitors. It means they didn't use it. Because trust me, if they use it, they will mention it. It's way more expensive compared to other capacitors. So that's the first level, the lowest one. And then the second one is called, they were marketing on main Japanese capacitors. So main Japanese capacitors means, Means the big ones like this one, the big ones are made in Japan, but all the small ones are not. And then the third level is Japanese electrolytic capacitors. That means the big ones, smaller ones are all made in Japan. And they are actually the best, the highest level. It's called 100% Japanese capacitors. It means that every capacitors, big, small, everything inside, electrolytic, polymer, are all made in Japan. So usually when you buy a power supply that has a higher wattage or higher efficiency rating, you want 100% Japanese capacitors.
So is that true then, that if you want to reach a higher efficiency level, the 80 plus platinum, titanium level, you also have to use higher quality components to actually reach that? Is that correct? So you can't actually use lower end power supply components to reach the higher efficiency level?
That's a great question. Yes, but some company has like very good PCB board design. They might able to use a regular or lower end component to reach the same level. But I would say usually just use the best quality material and the best quality design to make sure that your power supply is the most premium.
So it's interesting that the 80 plus rating doesn't necessarily showcase the power efficiency, but also the quality kind of the power supply. Because, usually you go more efficient, it's more higher quality as well. So the quality and efficiency run together.
Yes. Primarily, they test for efficiency, but they also offer testing in a lot of different criteria. Another thing is, 80 Plus is actually not the only organization that issues PSU certification. There's another one called Cybernetics. So people probably see it in the color box of different power supply. They will have an 80 Plus logo and Cybernetics logo. So Cybernetics it's a new organization that does that. It's a great thing that we have a second option for PSU testing. So the funny thing is, and there's actually a rating. So we have platinum, we have gold, we have titanium, but there's a rating that no brand can ever meet. Like nobody has successfully meet this rating. That is Cybernetics Diamond Standard.
And what does it mean? What?
So basically, it means that they have a lot of impossible standards in terms of efficiency and in terms of safety and everything. So nobody ever reached that standard yet. So I mean, if anyone reached that, if everyone became the first one who reached the Cybernetics Diamond Standard, it means they're gonna earn millions and millions of dollars.
What do they have to do? 100% efficient and 90 plus gold or something rating. I don't know. It will grow trees out of the PSU. So when we're talking about power supplies, obviously the other thing you see on power supplies is the wattage. We've got the 1050 watt power supply here, and there's 850 here as well. So when we see 850 watts, 1050 watts, what does that mean? Like, could you explain the wattage to us, and how do people get, what does it mean?
Yeah. So a wattage in a power supply, it indicates the maximum power output capacity. Like, to put it simply, because we also have spikes and a lot of different things, but to put it simply, it means the maximum power output capacity. So in the other word, for example, 850 watt power supply can deliver up to 850 watts to computers' internal components, like CPU or GPU, more stably. So when you look at Amazon or when you look at the market, you will usually see a lot of different variation. Usually started from 650, 750, 850, 1000, 1200, 1500, 1600. And in a very rare occasion, you will see a 2000 watt power supply. Very rarely. And it has a catch to it, because it depends on different kind of power outlets in different regions. I believe in UK it's 230 volts in terms of region output. But in Japan, we have 115. And USA, we have 115 too, right? So for 115 region, it's impossible to have a power supply that give out 2000 watt. energy. 1600 watt is the highest for America and Japan. But for places like UK, 2000 watt is possible.
So when we see the wattages, you mentioned, 1600 watts. The watts is basically what the electricity is measured, or the power outage is. It's a measurement. But when we see that there's a 1600 watt power supply, for example, let's say, because this goes, worldwide, it works for everybody. Can this hurt your PC when you put two powerful PC or PSU inside a PSU? For example, you've got a PC that only needs 500, let's say, but you put 1600 watt power supply in there. Does that hurt your PC?
That's a great question. You will not hurt your PC because, as we discussed before, power supply give out power in terms of loads, different kind of loads. So it will only give out power when you need it. So when a system needs 100 watts, it will give 100 watts. So buying a bigger power supply will not hurt your PC. Actually, it can help you by increasing your future upgrade potentials. But if you buy a smaller power supply than the one you needed, or the power supply that just barely meet the requirements, then it's more tricky. It's going to be more difficult. It might hurt your power supply, or it might lower its efficiency. So always buy bigger. It makes more sense.
So that's good to know. The power supply doesn't actually push power out. It lets the power to be drawn by the system. So it doesn't actually hurt. So that's good to know as well. So the last kind of question I have before we go to level 2 and into more expert and more interesting perhaps topics to some people is how do you choose a good power supply? Because there is a lot of these specs there. There's another one that's called modular and semi-modular, fully modular kind of spec to power supplies. If you are, let's say, on a budget and you may be a beginner, how do you choose a good power supply? What are some of the things that you should be looking out for?
Let's start with modular first. So modular, we have three different kinds of modular design. We have full modular, we have semi-modular, and we have non-modular. So if we think power supply as our heart, then the different cables of power supply actually means the van. They connect the heart to different components, right? So then when it comes to non-modular power supply, it means I actually have a sample here. We have a non-modular power supply here. It means that all the connectors are connected to the power supply. We don't got to choose which one to be on and which one to be out, right? So there's no socket here. That's the non-modular power supply. It's usually the cheapest power supply. Sometimes you won't need to use everything. So you're just gonna get like super difficult and it's just gonna make your cable management disaster. So we have something called a full modular. So when you look at our power supply, this is a full modular. It means that you just can't clean, just one power supply and a lot of sockets on the back. And a huge bag of cable. That's right. That's full modular. Usually, it has a lot more advantage in terms of cable management, and then we got to pick and choose which one to use. But it's actually the one in the middle. That is called the semi-modular. So as you can see, this one is called semi-modular. It has a connected cable and all those sockets that we got to choose. So in a semi-modular power supply, all the vital cables are forced, but the optional ones are optional. So this one is actually a little cheaper than full modular one. And in different countries, like I know Japan still prefers this kind of things. And then some European countries like Germany will still use it. But in America, basically everyone, like every DIY builder would prefer full modular because of its cable management. It's like you don't want to spend a lot of money on a beautiful case just so you look terrible with all those cables.
Just a quick interruption. If you're enjoying this and the channel, what we're doing, and you'd like to support it, why don't you check out TechNotice merch at technoticestore.com and use the code LAURI, Lauri, to get 10% off. Thanks guys for watching, and back to Dio. So now, how do you choose a good power supply? What are some of the things that you should be looking out for?
When we pick a power supply, the first thing we need to do is to evaluate your system requirements. So for DIY users, it's common for them to choose the power supply the latest, right? So you can use a lot of online PSU calculators like Enermax. We have our own PSU calculator. Just Google Enermax PSU calculator, and then you can just fill in all the components you need, and then it will give you a number of the required system. But the catch is you don't want to buy just, the power supply just meet the requirement system. You want to buy like 30% higher in terms of wattage. So, and let's say that you have determined the desired wattage and efficiency rating. You want a 1000 watt gold plate power supply. Then, you need to consider following things. You need to consider number one is brand reputation, because a more established brand usually have better protection system against like power surge and energy fluctuations. You also need to take care of, you need to do some due diligence in terms of the brand's track record, because there are a lot of new brands nowadays that people never heard of, and it's just pretty weird. So you want to buy power supply from a from a brand with long-lasting reputations. Mm-hmm. Like in Enermax, we actually have 33 years of experience making power supplies. A better strategy for consumer is to consult good resource like Tom's Hardware, or just watch Tech Notice.
Hey.
And then another thing people need to worry about is warranty. So just before you buy your power supply, always look at the warranty, because the longer warranty is, it often signifies the confidence of the product's durability. For example, for gold rated power supply, always look for warranty that is 5 years or higher, right? So if you want to buy a platinum or titanium level power supply, ideally you want to have a 10 years or higher than 10 years of warranty, because they reflect like how confident they are to a product. A little catch is that some new brand will offer like impossible long amount of warranty. Like some new brand never heard of will say, hey, we'll give you 12 years warranty. But the thing is, we don't know if they're gonna be here in 12 years. Yeah, and then so after you check the company and the warranty, and the third one is fun. You got to pick the unique feature for power supply, because although the primary function of power supply is to convert AC to DC, they actually offer a lot of different features. Like for example, if you are overclocker, you will want power supply with some kind of digit in it. Use our product as example. This is DFX, Revolution DFX. So if the viewer is aware of Tech Notice's back to school giveaway, they will see this before. So the reason why we call it Revolution DFX, DF is actually a special technology we call dust-free rotation. So this feature will help the PSU to clean itself. So every time you open it, it will clean the dust out. So there will be no dust or other things go inside of the power supply. That's why we offer 10 years warranty for this product. And also we have side panels and a lot of other features. Yeah, so the third thing consumer want to do after they check the warranty and the company is they got to pick which PSU feature they like or they need. And usually power supply with more features are more expensive. So do consult with your wallet. And yeah, that's it.
I would say as creators, don't overly get clogged up about the features of the set, because there's a lot of features that you probably don't need. Like a lot of the RGB, perhaps you might not even see it underneath there, or decide if you want the semi-modular or modular power supply. But to me as a creator, some of the most important features are the power efficiency and the warranty from a reputable brand, because you know that if you get a good power supply, it will last you many builds. This is some of the components that you can just bring on and on and on to the next build, and you can keep it. But then now we're going to start a little bit of a different conversation, which talk about some of the features that are like new, which you might have seen now on power supplies as well. There's PCIe 5.0 and ATX 3.0, 3.1 specs, and so on. But I want to start this with a bit of a different question. I'm sure you've heard and seen the Gamers Nexus video about the power supply explosion, which created a very interesting conversation on the consumer side. But I haven't actually heard any feedback or opinion from the manufacturer side of the story, because GN did share some of the, I think, emails or something what Gigabyte was sending to them. But I'd love to know, what do you as an Enermax employee, as a manufacturer, think about that whole, drama? Is this something that we should be concerned about? Tell us what you think, because I'd love to know your opinion in this.
No, that case is definitely very dramatic. So I still remember that. I still remember watching that video, and then my colleague is like, "You need to see this." That was crazy. So I think that was back to in 2021. And to me and to manufacturers, it's more a PR disaster than a product design disaster, because Gigabyte they messed up in PR. Like, they messed up too much. Yeah. So just recap the story. So basically, I think back in 2021, the first thing they did that is a little controversial. It's they actually bundle this specific power supply. I think that's in the GP 850 GM power supply. They bundled that with the newest ATX 30 series graphic card back then. So if you want to buy an RTX 30 series graphic card, it comes with the graphic card. So then people start to the Gamer Nexus and other reviewers start to realize that, hey, almost 50% of those power supplies failed, and what is going on there, right? And then a lot of people started to do a lot of rigorous testing, a lot of different testing to show how easy it is to break it. And then Gigabyte just come out and blame everyone. It's terrible. From manufacturer perspective, it has the problem from our perspective is called, it is caused by something we call OPP. So OPP stands for the overpower protection. So basically, overpower protection is a common safety mechanism that allowed PSU to automatically shut down if the power draw exceeds their rated capacity. Let's say, if I have a power supply that is 1,000 watt, and then I set the OPP, overpower protection, at 1,300 watt. So as soon as the power draw exceeds that amount, it will shut down. Right? So the issue of that is Gigabyte had their OPP set a little too high. So people were able to push their power into a limit without the power shutting down.
Just to quickly ask about that. So what is the normal power OPP like level? Is it 120%? Is it 150%? And what did Gigabyte set it's there? So what is the bad limit and what is the good limit?
I think in this case, Gigabyte actually set their 850 watt power supplies with an OPP of 1,300 watt power supply. That's like crazy. 850 watt to 1,300 watts. But usually when we designed it, we'll design different OPP depending on the number one, what level of power supply it is and how big it is, right? And then we'll do all kinds of testing. So in this case, in Gigabyte's case, 1,300 watt is probably too high for their 850 watt power supply. So after this incident, they actually lowered that. They lowered it from 1,300 watt to 1,000 watt. And then you solve the problem. The rule of thumb is, don't push your computer this high, because like I would say that for regular consumers or for content creators, you don't need to worry about it, because in real world scenario, it's very unlikely for a power supply to be fried. And you're going to need a very specialized or highly technical set to set up this, to push intentionally to push your power supply to this limit, right? So even in our most extreme user scenario, these kind of things don't usually happen.
Okay, so is this problem actually a problem then? Is it actually dangerous to use a power supply that has a very high OPP, set there? Is it dangerous to push an 850 watts to 1400 watts power draw?
Well, it's pushing it is definitely a bad idea, but I would say it doesn't really happen. And Gigabyte messed up because they give a lot of people incentive to keep pushing it and to see how terrible their power supply is. So again, it's more a PR issue, because if you try to push like every power supply to its limit with some specialized tool, the chances it's gonna break at some point. But usually it wouldn't happen in user scenarios. It doesn't work like that. But the funny part is that the new ATX 3.0 standard actually asks power supplies to handle a much higher power spikes. So in ATX 3.0 standards, this kind of issue is not likely to happen. The possibility of it happening is even lower.
So I've got the DFX 1050, which is ATX 3.0 ready, and I am literally I think right now, or in about 5 minutes, there's a video coming out on my channel where I use this power supply. Interestingly, I did. This is a coincidence. I didn't schedule it on this day, but I actually used this on the Xeon 3475X, and I wanted to see how far can we push the Enermax 360 millimeter AIO that's meant for those Xeon processors, the LIC-Tech 2. And my room temperature was quite high, which means that, I'm going to hit the thermal limit a bit higher. But we pushed it to 900 and something watts with this power supply. But from the wall, this power supply was drawing over 1300 watts. So this ATX 3.0 spec, as you see, I don't know what the OPP is set for this one, but I was easily pulling 1300 watts with this one, which is probably not what people should be doing at home, but we were able to do that. Go watch the video. You mentioned ATX 3.0 specification, which I can see in here. One of them is 3.0. This is the, the DF2 is not 3.0, right? And then the Revolution DFX is 3.0 standard spec. What is an ATX 3.0 standard or spec?
Yeah, that's a great question. A lot of people are confused about this. So an ATX 3.0 is the latest specification, from Intel for power supply. So and it was released in the early 2022, and back then it was one of the biggest things. It was one of the biggest thing in the PC community, because the last thing, this kind of big updates from Intel was like 2 decades ago. That was 2003 when they released the ATX 12V 2.0. So it was 20 years ago, right? So this new spec, this ATX 3.0, it represents a significant upgrade to meet the needs of the modern computing system, because nowadays the graphic cards and processors became increasingly powerful. So we need a new standard to deal with that. So, and that is ATX 3.0. And there are tons of testing criteria for Intel's ATX 3.0 standard. Some are required standards, some are recommended standards, and there are a lot of them.
So what are some of the required at first? What are some of the required to actually get an ATX 3.0 standard on your power supply? What are some of the specs there that you have to meet?
Yes. So the one of the most important one, at least for for manufacturers like us, is the enhanced spike handling. So ATX 3.0 actually asks power supply to handle a 200% power spike. So for example, if I have a 1000 watt power supply, you ask this power supply to handle a 2000 watt draw for 100 microseconds. So just very short amount of time, but it's a new standard there. And this one is really hard, like for us to design, for us to make. And so this one is definitely one of the most important one. And then just so people know, 100, and so 1 second is 1 million microsecond. So in this standard, the Intel ask our power supply to be able to hold 200% power spike for 100 microseconds. So just a little bit amount of time. Yeah, this one is definitely the most important. And
it's so short that most people won't be able to measure it in any of the software spikes, I don't think. Is that correct? Can you even measure it on software, hardware monitor, or something like that? Is it possible to measure those spikes, or do you have to have some special tools to actually plug in between some of the power cables?
Yeah, you do need some special tools, but I think it's easy to get. I don't know, maybe because I'm working here. So we have some like digits and gadgets that we can just monitoring the power outlet of the power supply. So I think it's easy to buy it from Amazon. Probably just $15, $20.
Oh yeah.
And yeah, it's possible to do that.
Okay, so we've got the increased power spikes. What else is the 3.0 standard?
And the other one is the new 6-pin cable, the 12V high power connectors. So this connector actually has a specialty that is the only thing, it's the first thing that can deliver up to 600 watts to a single graphic card. So before this design, they cannot reach this high. So this cable, this 12V high power connector allow power supply to draw 600 watts to one graphic card. So, and this is one of the significant change. The other one is that it enable power supply, enabled graphic cards to communicate with power supplies in terms of how much power to draw.
That's interesting, because there's like two separate types of these 12-volt high power cables, isn't there? There's one that have 16 pin on one side and then 16 pin on the other side. And then there's also some that come with some of them, like power supplies, or you can buy one that has, you know, 2 8-pin PCIe power cables to 1 16-pin. Is there a difference between these or not? Both of them show that you can do 600 watts through this one cable.
So technically, they are the same. They're the same thing. The difference is, so for some power supplies like our DFX, we have a native outlet for the 16-pin cable. But some other power supplies, like our DF2 or Corsair's, I think it's RNE series, like they don't have a native outlet for this. So they need to use an adapter. So the adapter usually has one side that is an 8-pin, the other side that is 16-pin. But it basically does the same thing.
Very interesting. Another thing I want to ask about this cable while we're on the cable is that the 16-pin cable has these, you know, you have 12 kind of big connectors and then 4 smaller on the top. Sometimes you don't have all 4 cables in those pins. I'm looking at the cable, for example, right now that's on the DF2, and I can see there's only 2 little cables, but then some of the native ones have 4 of them. Is there a difference of these little things or not?
Yes. Like you can see the little thing here.
You've got 4 of them.
So the different thing is, according to the Intel design guide for ATX 3.0 standards, there are 4 pins and 2 pins that is required and the other 2 pins that is recommended or optional. So it's not really required to to be able to be called ATX 3.0. So the required one are called the sensors. So the sensors is in terms of 0 and 1. So those sensors allow this cable to have 4 different outputs, to have 150 watts, 300 watts, 450 watts, and 600 watts. So basically, those two sense decide how many power to draw, how many maximum power to draw. And the other two sensors are called, I call it like a power stabilizer. Basically, their function is for safety. They basically communicate with the power supply to see if the power supply is connected like properly, or if the cable is still alive, or if there's anything wrong with the cable. So the other two is more for a safety reason, but it's optional in terms of ATX 3.0 design.
So when you've got a native 16-pin cable, would that then have all 4 of these as well?
Some will, some won't. It depends on the brand.
That's interesting. Okay. So is there any other specifications now for the ATX 3.0? So far, we've got this cable. We've got higher spikes. Was there anything else?
There are actually a lot of other things, but people don't really need to know about it. It's more for manufacturers, really.
Okay. So is it to do with safety? Is it to do with handle power more? Is it more efficiency? What are these other like specs to?
So it is to do with efficiency, to reduce energy waste, and it has anything to do with to communicate power delivery and to better power graphic cards. So some internal and structure things we need to care about. But for consumers, really, they don't need to worry about that.
Okay.
They just need to worry about the power spike and the new cable. But then we also need to talk about the PCIe 5.0 standard.
Yes, I was going to ask you about that. Go on.
So PCIe, I think it stands for like peripheral components interconnected something like express. It's a standard.
It's to do with data, isn't it?
Yes. It's a standard for transmission speed. So, like a lot of power supplies will package itself as a PCIe 5.0 ready. But PCIe 5.0 is it's like a transmission standard for graphic cards. It really has nothing to do with ATX 3.0. Because in ATX 3.0, actually, we talk about design of power supply, whether the design of power supply can pass the Intel standard. But PCIe 5.0 has nothing to do with that. It has everything to do with the cable. And that's it. Like if your power supply has a cable, 12V high power cable, and you can use it, then it's PCIe 5.0 ready. So, and again, the difference between ATX 3.0 and PCIe 5.0 is that ATX 3.0 is a standard for power supply. PCIe 5.0 is a standard for graphic card or for transmission speed.
So if the power supply box says that it's PCIe 5.0 ready, that doesn't necessarily mean that the power supply is ATX 3.0. That's exactly. Okay, so it basically means that there's just a cable provided like this one here.
And remember that one of the most important spec for ATX 3.0 is the spike, 200% spike, right? So usually, like if they are not ATX 3.0 standard, they don't have all those fancy things that ATX 3.0 standard provides.
Why is this called PCIe 5.0 cable? Is it PCIe 5.0 cable then? Because some call it 12-volt high power cable, 16-pin, but then it's also mentioned sometimes as PCIe 5.0 ready, which means that like if the PCIe 5.0, this is where the confusion comes, means data transfer speeds, like Gen 5 speeds, we have some gigabytes per second linked to that Gen 5 speeds. But then we have a cable for this that's got nothing to do with data transfer, but just power delivery. Is it the same thing? Where's the, like, why is it called PCIe 5.0 not 12-volt high power cable? Are these the same things?
Those are not the same thing, because in PCIe 5.0, it's again a transmission speed standard, and 12 VO high power cable, it's really just for graphic card. But I think why people connect them together is because of the NVIDIA graphic cards. They are PCIe 5.0 standard graphic cards, and they can be powered with a 12V high power cable. So technically, 12V high power cables are the cable for PCIe 5.0 graphic cards. So that's a PCIe 5.0 graphic cards in this weird logic.
Here's the paradox. There's no PCIe 5.0 graphics cards out there. But what I mean is, there's no, even if we look at the most powerful graphics card right now, the NVIDIA RTX 4090, it's still PCIe 4.0 x 16.
Yes. So that's crazy. Especially the 4060, 4070 don't even use the 16 pin.
So that's the confusion. I guess it will make sense maybe in a few generations where we have Gen 5 graphics cards, but right now we don't have it. And we had it on the previous one as well. The 3090 Ti, I believe, had this new adapter as well, which is crazy again. NVIDIA started to introduce this type of cable even on the 30 series with some of the converters, but then they didn't have the extra 4-pin attached there. Is that correct?
Yeah, they tried to push it like different version of it before.
So that's confusion. And who makes the PCIe 5.0 standard? Is it Intel? Is it what?
No, PCIe, it's an organization, basically. It's an organization for transmission speed. So PCIe makes PCIe 5.0 standard. And then ATX 3.0 is an Intel standard. So I totally agree with you. It's the whole thing is crazy. So, Lauri, this is an example of how the market just drives, how consumer demand change product. So, because everybody all of a sudden are talk about ATX 3.0, PCIe 5.0 stuff, although they don't really need it, but because everyone is doing that commercial, like if we don't do it, it's going to be like super weird. People are going to think that, is your brain falling behind? So we're going to have to do it. So the expectation, upon expectation, right now the situation is very weird. And the worst part is that it makes everything more expensive, right? Because we're trying to come out with new standard. We're trying to meet a new standard that people don't need. And they're buying new standard they don't need. So it's just a very weird market right now.
And what's your thoughts about the gray area on Amazon about different, because when you go on Amazon and start to look at ATX 3.0 power supplies, there's all sorts of dogs and foxes that come out that you've never heard of that say that, and say that this is, all of these phrases are almost misused. ATX 3.0, PCIe 5.0, 12 volt high power cable, all these things have been like kind of just spilled out there. What's your experience in this as a professional power supply manufacturer? So
when it first started, it was crazy. It was crazy. Like sometimes Jake will call back and say, "Hey, do you see the labels? Like, what does that mean?" And we'll be like, "We don't know what that means." So, when new standard emerged, a lot of people are going to try different kind of marketing, especially in this very confusing situation where ATX 3.0 standard PCIe 5.0 is just very confusing. So a very common misconception people have, again, it's to think that ATX 3.0 and PCIe 5.0 is the same thing. So again, in some Amazon product, they will say, "Hey, our product is PCIe 5.0 ready," so you can. And then they use this product to compete with ATX 3.0 power supplies, which is just not right. And it's super weird because it means nothing in terms of comparability. I think there's a very easy solution for that, actually. There's a very easy solution. It is to just, before you buy an ATX 3.0 power supply, just Google Intel power supply selector. Just Google Intel power supply selector, and they're gonna come out with a link that take people to a list of Intel certified ATX 3.0 products. So basically, we can send our product to Intel and say, hey, can you please verify that is ATX 3.0? And then Intel will do it. They will do some tests, and then in the end, they will say, hey, you are certified to be ATX 3.0 based on our standard. And then they're going to put us on the online list. So customers can go to this online list to see if that's real ATX 3.0 compares to the PCIe 5 ready mumbo jumbo. Yeah. And another thing that may cause confusion is sometimes an ATX 3.0 standard power supply does not have a native outlet for 12V high power cable. So like DF2, our DF2 is one of the example, and Corsair's RME theory is also one of the examples. Like they don't really have a native cable, but in terms of power supply, it fits all the necessary standard in terms for it to be ATX 3.0. So again, a very easy rule of thumb is to Google Intel power supply selector and to see which one are certified and which one are not.
Another question I have is, in terms of the 12 volt high power cable, obviously this is a new cable, and one of the benefits of this is that it delivers more power per cable compared to the PCIe 8-pin cable, which I believe is 150 watts. Because my point is, this 600 watt power cable, the benefit of it is obviously you've got more power per single cable compared to the previous generation. You know, NVIDIA gives you an adapter of 4. You have to plug in 4 PCIe 8-pin cables to get, you know, one of these. So less cables, more power. But the other bit is the cable rigidity and kind of strength, because you can also see, which is a big drama that's been out there, again, supported by Gamers Nexus, with the power cable melting and burning. And what's your take on this? Is this another one of those dramas that's been like exaggerated, or is there actually some, you know, more kind of meat to it, that this is actually not as good of a cable as the last one?
So this one is actually a very good question. It's exciting. So this is actually the legit issue. So and let me answer the previous question first. So for a 12V high power cable, itself have 4 different variations. We have 150 watts, 300 watts, 450 watts, and 600 watts. But the cable itself can handle 600 watts. It is the sensor here. So 2 sensors will decide what kind of maximum power it uses. For example, a 150 watt cable are controlled by those 2 sensors, not by the cable itself. So basically, every cable is 600 watts, but it is controlled by those sensors to give out 150, 300, or 450 or 600. And then for the bending issue is actually legit. It's a legit issue. I remember like when the first week of NVIDIA's 4090 release, there are like 10 to 14 cases. That was crazy. And now I think there are more than 50 cases of burning. So
is that just with Enermax cables, or is that like worldwide?
Oh no, worldwide. Like our cable never burned. Yeah, our cable never burned. So we're very confident. So again, when this happened, we were super nervous. So when the news happened, says, hey, you know that a lot of 12V high power cables are burnt, we were like super nervous. We had to start to analyze all of our cables to make sure that everything's right, to make sure the same thing wouldn't happen to us. A lot of people has different hypotheses, different theories for this incident. For example, NVIDIA say that this problem is caused by user's mistake. They say that it's because user didn't connect the cable with the graphic card properly. which might be true, right? But according to other people like an Igor's lab or other media, they suggest that most of the burn cable have their contact burn. Contact means like those contact. So it's the contact that burn. So really, it's just the material. Yeah. So it's the contact that burn. So basically, when it comes to contact design, as you can see, it has 12 contact here. When it comes to contact design, each contact actually gonna have different tolerance and different material, so on and so forth. So a lot of people think that those cable burned because of the design of those connectors. So again, everyone is telling us different hypotheses and different answers. But personally, like as manufacturers, we would think that the second one, which is the connector design, it's more viable. At least it's more important for us. So we actually have to rethink about like how we design our cable and what material we use, these kind of things. So to solve this problem, different brands actually do different things. Like some brand actually color the different part of the cable. For example, some brand will color it yellow. So you have to connect it, push it all the way in until the yellow parts are unseen to make sure that you plug it in like properly. But for Enermax, we actually prioritize the product safety. That's why we try to work on the material of the connectors. So we actually, it may not mean anything to people. It's highly technical, but our current is each one of those contacts are rated with 9.2 per contact current, and all of them we use a 16 AWG wire. It's a material to handle the current. So basically, we use a better material, and we make sure that each one of those connectors can handle just more power, more current, so it will not burn.
So in that burning solution, I think Gamers Nexus concluded that basically it's not plugged in correctly that causes the burning. Is there any other solutions that you recommend people have apart from that, or is this basically the cause of burning cables, or is there something else that can be there as well?
Well, I think one of the biggest issue is like if we really deep dive into NVIDIA's issue, we'll find out that they have two cable manufacturers, and one manufacturer actually have a higher probability of burning cables. So it could be design, it could be material, but I would say that as this technology became more matured, customers don't really need to worry about it anymore because there are more and more cases in terms of a good design. And but if customers really want to avoid this kind of things from happening, the best thing will be always buy from reputable brands, from big brands, and use 12V high power cables. That is, they come with power supplies, right? Because usually those are specially designed for the power supply. So it's, again, less likely to burn. But also just make sure that you connected it properly and don't bend it too much because it's going to hurt it. It could hurt it theoretically. Yeah, but I would say that as this technology getting more matured, the probability of it happen again will decrease significantly.
You said that there's about 50 cases of burning in the world now of these cables. May I ask how many ATX 3.0 or PCIe 5.0 standard power supplies has Enermax sold? Rough number.
Maybe not a million, but like far away from a million, I think. And I need to ask Jake about it. But we sold a lot.
Hundreds of thousands? Is it hundreds of thousands?
I really need to go back and see different data. Our 80X 3.0 product just kick off. So I don't really know the exact number, but we sell a lot of them so far.
So is it thousands? Is it tens of thousands? Is it hundreds of thousands?
Hundreds of thousands.
Okay, so there's been hundreds of thousands of
Yeah.
Enermax power supplies sold. Not a single cable has gone. There's other power supplies in the world. And there's probably, I mean, not probably, there are millions and millions of power supplies being sold with these. There's millions of NVIDIA RTX 4090s out there.
Yes.
And we've heard of 50 cases. So the probability that you're going to be having this, if you plug it in,
yeah,
you're more likely to get bitten by a shark, most likely, than this burning. The probability is very, very low.
Yes.
I mean, we know now how to prevent it. It's basically just no bending, plugging it in. That should usually solve it. But there is also something that you mentioned about the ATX 3.1. Intel's another standard. Is this something that we should worry about, think about?
Quick answer, no. But Intel's ATX 3.1 is there's a rumors like in the industry saying that they're going to be a new standard now and full safety basically. But all we need to know is this new standard will not replace. Well, it's completely compatible with ATX 3.0. In fact, it's actually a little less harsh in terms of testing criteria. So if a power supply can pass ATX 3.0, it can definitely pass ATX 3.1. I think ATX 3.1 put more work on the cable itself. But again, Intel still haven't decided which one to do. So again, still on the air. We just heard rumors right now. But all we need to know is that we don't need to worry about in terms of power supply. So users don't need to change power supplies if there's a new ATX 3.1 standard come on.
So basically, all the standard will be some little things to do with safety inside the power supply, nothing to do with cables or anything major like that.
Yeah, everything will be nothing big, and the cable might change though. I think they might change the design of the cable. Yeah, but again, we still don't know what exactly going to happen. The rumor says that the cable going to change, but I would say don't worry about it because
what part of the cable might change? Is it the 12-volt high power actual 16-pin end that might change?
Yeah, the rumor says that because right now there's a two sides, right? There's a power supply side and the graphic card side of the 12V high power connector. But the new standard going to be like it's interchangeable, so you don't need to worry about changing it. But again, nothing is concrete. We still need to wait for more definitive answer. But the cable might change, but don't worry about it.
Okay, so basically, the 5090 most likely are not going to have a different power connector. It's not going to happen.
I don't know, actually. You might, because I heard a lot of different informations. I don't think Intel released that yet, but basically the design of this 12V high power cable might change. They're going to do something to make it safer. They're going to do something to make it more user friendly. And that's all. Like they might increase the length of some of the connectors to make it a little longer. Yeah, but they haven't released it yet. Just rumor we heard. It might change.
So we might have another adapter.
Yes.
We need to worry about.
Potentially, yes.
Okay. But in terms of other cables, is there any other standards that might change? Is there a reason why we couldn't have this also as an EPS CPU connector? Why do we have different connectors for the CPU instead of GPU? Could we standardize? I mean, could Intel standardize these connectors by saying, look, why don't we just have all 12-volt high power connectors to the CPU, GPU, PCIe, anything, so they're all the same? Because right now we have these, we have the 8-pin, we have the 6-pin, we have well, SATA is 5 volts, but could this happen? Could we have more standardized cables?
Actually, it's unlikely for this to happen because right now power supply, in terms of a graphic cards start to draw way more power than we expected. So this cable is actually designed to cater to the need of graphic cards. As for CPU, I mean, it doesn't really draw as much power. I mean, the power consumption, the TDP is increasing every year, but it's not in the extent of GPU. In terms of power design, we will be using this for GPU for a while longer. Yeah.
Okay. Well, we've got the Xeon processors.
Oh yeah.
That are pulling 400 watts at stock. So we're getting there. So the last thing that I'd like to ask is Intel's 12VO standard, and what is that?
So Intel's 12VO design stands for 12V only. So in a power supply, we usually have 3 different kind of wattage. We have 3.3V, we have 5V, we have 12V. So that actually goes back to the previous question, like why we have different kind of cables, right? Different kind of cables actually give out different kind of voltage. That too. So a 12V only design, it means it only have 12V. It doesn't have 3.3V or 5V. So this design actually boosts power efficiency and enhance efficiency, but also simplifies the power architectures, and so it doesn't need to shift voltage around in the motherboard. So the advantage of that is it significantly reduce energy consumption, especially in a low load or standby state. So for example, if you have a machine maybe like a kiosk that will be standby for a long hours, a 12VO standard will actually save a lot of energy compared to other standards. Intel has been trying to push this standard ever since 2019, because 2019 was the time when we start to realize that, hey, the earth is burning. We need to care more about our environment. And so they try to push this standard, but the issue is that it's going to make motherboard a little more expensive. So a lot of motherboard manufacturer doesn't like it. So back then, it wasn't a thing, although Intel has this standard already. And then what happened after pandemic is that people start to pick it up again. People start to realize the importance of 12VO in terms of environment. So a lot of motherboard companies started to build motherboard that has 12VO, that supports 12VO standards. And those will save Earth in terms of creating a more greener technology. But here's a catch though. The catch is that you cannot use a regular power supply on a 12V only motherboard. You need to use a specialized 12V only motherboard on a specialized 12V only power supply on 12V only motherboard. So if anyone wants to build a more eco-friendly system, they're going to have to change a lot of things. Allow me to do some promotion here. So the good news is in Enermax, we are the first one to come up with a new patent that combined ATX 3.0 and ATX 12VO. So we call this power supply Platinum-X Gemini. So Gemini stands for twins, so it can stand both ATX 3.0 and 12VO. So I think WCCF Tech actually did a piece on this product. So what it means for user is that they don't need to be caught in the crossfire, of needs between these two standards. They can use one power supply for both 12VO motherboard and regular motherboard. It's going to be our new product very soon. It's called Platinum-X Gemini, and we have this product to support Intel's their effort to push the new 12V standard.
Okay, so let me understand the 12V only spec. So basically, the power supply only provides 12 volt to the motherboard, not different voltages anymore. But there's still some components of the motherboard that would operate on a 5 volt basis, right? Like the
Yes.
Ender 2 SSDs, they are on a 5 volt, if I'm not mistaken.
Mm-hmm.
They don't take 12 volt. So where does this power get converted then? Does the motherboard have to convert the 12 volt to 5 volt? Is that where the conversion happens?
So I think what happened is a 12V power supply will only, the conversion started inside of the power supply. So when the power supply convert AC to DC, only give out like 12V power.
Mm-hmm.
And then I think the motherboard, the PCB board on the motherboard going to do some fancy things to transfer that. Yeah. But because the saving energy part started from the power supply, right? So as long as the power supply only give out 12V, it fit the purpose of the 12V.
Would the SATA connectors change then? Because SATA is 5 volts. Is that correct?
Yes. In fact, some brands started to use converter to put a regular power supply to 12V to output 12V only. But again, the issue is then the power happens. I mean, the whole the whole conversion process happened inside the power supply. So if I use a cable, then it defeats the purpose of saving energy.
Yeah.
So yes, I can then support a 12V motherboard with regular power supply with a specialized cable, but it defeats the purpose of 12V.
Okay, so right now on these motherboards, which one of these connectors supplies other than 12 volts? The motherboard connectors, that's 12 volt, isn't it?
Yep.
The PCIe and CPU connectors, they are 12 volt.
Yep.
So,
no, I think different. Again, I might need to go back to study because I think different one will give out different voltage.
Okay, I see.
So I need to ask RD about that more. Sorry. Yeah,
I
this
think
one
you're
is
right.
a little confusing to me as well.
Okay, so they might change that. Some of these will only make 12 volts. Okay, I guess that makes sense. And then the conversion is still on the motherboard. So it kind of doesn't change anything, but just makes manufacturer's life a lot difficult, but nothing for the end user.
So
okay.
End user just need to know that 12V standard is good for Earth. And it's going to get more popular.
I just thought of two more last things that I'd like to ask you, which are, number one, how do you see AI impact manufacturing of power supplies? Is Enermax discussing how to use AI on it? Or is there, because AI is like the big talk, everybody's talking about it. AI everywhere. Intel's new chips are coming out. They're baked AI into everything. Is AI going to make a difference in any way?
So I'm actually dealing with a lot of AI projects myself. And there are actually two aspects. The first aspect is from the market, right? Because AI is getting more popular, so a lot more people start to demand workstations and server. So workstation and server actually use different kind of power supply. So it means a lot of us gonna start to try to see if we can get into that field to expand our business. And then in terms of how AI helps us, and I would say that it doesn't really, like for now, AI doesn't really help us in terms of designing a power supply, designing the PCB board of the power supply, because our RD are relatively more senior. So like David, he's still working on the other end. He has I think he has 29 years of experience building power supplies. So he's still, a lot of people still use the traditional ways to build power supplies in terms of PCB boards, which makes sense because when it comes to power supplies, we don't really want to, when it comes to the internal structure of power supplies, we don't want to be too experimental because it's safety concern, right? But we do start to use AI to design the look of power supplies. So we use a lot of AI generators to see and if our appearance can be better. And then we also use AI to write different commercial phrases. And like right now, I'm trying to build an AI-based customer service system for our clients. So yeah, it does help us in terms of marketing and customer service. But when it comes to design the components of power supplies, we still tend to use a more traditional way because safety is a concern. So we're waiting for some brave souls to try it out first and see what happens, and then we'll follow us slowly. It's been an honor, Lauri. Thank you. And,
thank you.
Yeah. So I'm just curious. So most of your viewers are content creators, right? Is there any specific need they have from computers? Like, doesn't matter if that's power supplies or AIO or cooling or the fans. Like we already know that the ARGB function is probably not very important for them.
Yeah.
A lot of fancy things, but like if we can build something specifically just for content creators, like what can we do? Like maybe we can work some ideas together.
Thanks Dio and Enermax for partnering up with this video to actually educate the audience, and we learned a lot of new things. And if you've made to this point in this video, you're probably going to be enjoying the same or similar conversation with JJ from ASUS, where we talk about XMP and all the problems and issues there, and a lot of misconceptions, and why you're not actually getting a post or you might be getting crashes on Windows. So go check out that right over there. And the Tech Notice merch, it's linked in the description below as well. See you soon.